Hey everyone, now get started at the top of the hour. For now, please enjoy this nice background music. Hey, sorry about the music. It'll be better in silence. So that is what we're going to do. We'll be starting in a. I'm looking forward to it. Okay, Charles from is here. I'm going to invite him up. So for those of you who it's your first time listening in, this space is an opportunity just to highlight some important people in the Ethereum community and app builders and get them a chance to talk about the apps they're building and just give a spotlight to the Ethereum community. And this episode is going to be a bit of a change pace as we're going to be covering some more wallets and accounts, but it's a very important topic, so I'm happy to give the spotlight to Ledger. And yeah, we might have some other co-hosts pop in and out, and it could be really fun. But for now, we're going to start with Charles, and we have a very important topic to cover here as they've recently announced a new ERC that's going to make transactions more human readable. And I'll let Charles give an intro, and we will go from there.
Yes, thank you. Hello everyone, and thank you for having me today. I'm going to briefly introduce the initiative that is brought by Ledger, and we have created an ERC, which is ERC 7730, and the idea is really to help securing the ecosystem. When you have a wallet on Ethereum, the security is something that is really important, and you have different properties that need to be fulfilled. First of all, you really want that your keys to be generated in a secure environment, and also you need the cryptography to be implemented in a secure environment so that your keys cannot be accessed by the attacker. But there is another property that is really important, and this is what we call clear signing. The idea is when you are interacting with the Ethereum blockchain, the EVM blockchain, when you are signing a transaction, if you are simply signing a hash, the problem is that you don't have any idea of what's going on with this transaction. So this can be very dangerous. And unfortunately, there has been a couple of examples in the past. Bybit is one of them, where the attackers succeed in swapping a transaction into a malicious transaction, and as the user has only have a hash, then he has no way to understand what kind of transaction he is signing, and sometimes there is dramatic consequences, and Bybit is such an example. And so this is the reason why Ledger has created this ERC 7730. And the idea for this ERC is to provide the wallet with all the information so that it can actually understand the transaction and put it in a human readable way. Because the problem is when you are a wallet and you are receiving a raw transaction, the problem is that you have the wallet has no way to understand, interpret, and properly parse this transaction, simply because the wallet doesn't have the context. So this is the reason why we have created this CRC, and the CRC is pretty simple. The idea is to create a metadata file that gives you all the information so that the wallet is able to properly parse the transaction. So we have created this format. So this is a standard format. Again, this is a JSON file. And if you are a DApp, if you are running a smart contract, you really know well how your smart contract is structured, what are the name of the method, what are the name of the parameters, and how to call them. And the idea for you as a DApp is to fill a metadata file that will simply describe your smart contract and say the name of this method is swap, and the parameters are from and to. This is the ticker, this is the magnitude, and all of this. So as a DApp, you create this metadata file that properly describes your smart contract. From there, then you will submit your metadata file that completely describes your smart contract into a registry. Today, Ledger is hosting this registry, but the idea is really to decentralize the registry. We really want to make this public good so that any wallet in the space can use this metadata file. And as soon as you have this registry that is clearly a mapping between the smart contract and its API and human readable information for this smart contract. So as soon as we have this registry, it's a matter of for the wallet to trust these files. So what we are doing at Ledger is to review this metadata file, understand that Uniswap has properly filled this metadata file, and this metadata file corresponds to Uniswap smart contract. So we are reviewing this, and at the end we are signing this metadata file. And as a user, when you are interacting with Uniswap, the wallet will craft the raw transaction and will send the raw transaction to the device, to the hardware wallet. In Ledger case, to your Flex or Nano or Stacks. And the device will receive the raw transaction to be signed along with this metadata file. And then with this information, the device is able to properly parse the transaction. And instead of simply showing the hash, the device is able to properly display that you are about to interact with Uniswap smart contract, and you are about to perform a swap from like ETH, like 0.1 ETH to 200 USDC. And then as a user, you decide if you consent to sign this transaction or not. And then as a user, you have all the information to take the right decision. And in this case, like you are like in complete security because your keys are properly stored in the device. The cryptography is implemented in the device. And you are not signing a hash anymore. You are signing something that is human readable, and you have like a strong security guarantees that the transaction you are about to sign is the swap with Uniswap, and it's not like you're not signing away your wallet to a joiner. And because as of today, this is a real big problem that we have in the space, and I think this is a collective responsibility in the space to fight against these attacks. And unfortunately, I can guarantee you that attackers won't slow down. They are going to be more and more sophisticated. A few years ago, attackers were only like collecting the low-hanging fruits, mostly trying to phish users by tricking them into asking them their 24 words. This kind of attack don't work as it used to be, and now attackers are getting more and more sophisticated. And we see like more sophisticated attacks where they are putting malware on the computer that directly steal your keys if your keys are in a software wallet, or even like there's a malware can simply swap the transaction into a malicious transaction. And unfortunately, this is not something completely theoretical. This is something that we see more and more on the field. Bybit hack was the biggest example. They lost 1.4 billion by simply signing hashes that they didn't understand. But the attackers won't stop there, and this is Bybit was just the biggest example. But unfortunately, there are many other such examples. So again, we are trying to make the ecosystem a safer place. We have created this ERC 7730 standard, and we are expecting the ecosystem to help us securing it even better. So we are expecting that to help us create the metadata file. And to do so, we have created a tool that really eases the process. If you are a DApp developer, you know best how your smart contract works, and you need like something like 15 or 30 minutes to create your metadata file. And then, so we need that to create the metadata file with the tool we have created. And then we need wallets to simply use the registry, trust the registry, and if you want to have the ledger integration of the ERC 7730, the idea is mostly to integrate our devices. So I'm really calling everyone in the ecosystem to help us securing the ecosystem and fight against these bad guys, because unfortunately they won't stop here.
An amazing intro. Thank you. It's really exciting that you're working on this and to make sure Ethereum stays more safe. Could you get more concrete about what developers need to know and how to integrate ERC 7730 into their apps?
Yes, cool. So you can have a look at our GitHub. So we have a dedicated GitHub repository that for now is hosting this metadata file. We also have a landing page on developers.ledger.com that explain the initiative as a whole, and also if you are a wallet developer and you want to integrate ledger devices with clear signing and all of this, we have created a device SDK that makes this process really easier. Back in the days, we didn't have a real device SDK, so that was a key lift to support ledger devices in your stack. But now we have created this device SDK, and it really makes the process really simpler. If you are a developer, it takes only a few minutes to integrate the device SDK and communicate with the device, and then you can you have high-level API to get an address, to sign transaction, to get the signing, and everything is very well integrated. So if you are a developer on the wallet side, it's pretty simple to do it. Also, we are going to work on creating a ledger button for that, so that can directly integrate ledger devices at the DApp level. So again, that will be very simple. So the button doesn't exist yet, but it will be based on the device SDK. So it shouldn't be so much work for us to finish it, and this is ongoing. And on top of this, we have worked on another feature that is pretty exciting. And the idea is to do a transaction simulation on device and transaction check on device. And the idea is the following, because when you do clear signing, you understand what type of transaction you are about to do, but it doesn't give you any insight of the risk associated with this transaction. And there are a couple of actors in the space, such that Blockhead, such that Tenderly or Cyrus, and they are doing this transaction simulation, transaction assessment, and all of this. But the problem is, if you have a malware on your computer, it might make you think that you are signing completely legitimate transaction, while when you are signing the transaction on device, it's a different one. So that's why I think it's really important that this transaction simulation happens on the device. And the way we are implementing it is the following, because as you know, ledger devices are not connected to the internet. So doing a transaction simulation on the device is pretty difficult. So the idea is the following. Whenever you are about to sign a transaction, the whole transaction is sent to these different partners like Cybers, Tenderly, Blockhead, and all these guys that are doing transaction simulation and risk assessment for transaction. Then, so we are sending them the whole transaction to be signed, and then they evaluate the risk for this specific transaction, and they create a risk assessment report for this specific transaction. This risk assessment report is signed by the transaction simulation, and then it's sent with the whole transaction to be signed to the device, so that the device has the whole transaction along with all the metadata to assign the transaction, and along with the risk assessment report that is given by Blockhead, Cybers, Tenderly, and all these different partners. So as a user, you have on-device, so on-device means that you have strong security guarantee. So as a user, you have on-device a risk assessment for this specific transaction, plus the clear signing of this transaction. And this is really the highest level of security that we can implement today on the device. So you have something that is disconnected from the internet, that gives you high level of security, strong guarantees on what kind of transaction you are about to sign, but also it gives you a risk assessment for this specific transaction. And then as a user, you can decide if you really want to sign this transaction while the device is is blinking, saying you that there is a critical threat detected, you can sign this transaction. But at the end, it's up to you to decide. We won't force anyone to sign or not sign a specific transaction, but we are giving the users with all the information so that it can take an enlightened decision. And it's not about signing a hash where you simply don't know. When you sign a hash, most of the time you are signing the transaction you intended to, up to the deep transaction that you wanted to sign, and it has been swapped by a malware or a malicious has been swapped into like a malicious transaction, and then you are signing a hash, and then you are losing all your assets. So this is something that we really need to fight against, and this is something we worked on for quite some time at Ledger. So I'm pretty proud to be able to announce there's new features. And again, it's not only a Ledger thing for Ledger users, it's really a matter of like securing the whole ecosystem. 7730 is for everyone, because at the end, building the trust is something important, because for newcomers, for people who are outside from the ecosystem, if they only share about like the biggest hacks and all these meme coins, gambling, and all of this, it's a little bit disappointing. I think. I really think we need to work on like recreating trust across the ecosystem, because we have built plenty of great technology, plenty of great application, and security is part of this trust.
Does this work for all types of wallets?
What do you mean by all types of wallets?
Like, I just want to clarify, not just Ledger.
Yeah, definitely. So ERP7730 is like a generic standard. It's a generic way to describe how a smart contract is working. And then as a wallet, you can use this standard to properly parse and the transaction and display it in a human readable manner. Whether you are on Rally, on MetaMask, on Trust Wallet, or on a virtual device, at the end you need to have like there's a human readable information so that you can take the right decision. So the difference with Ledger is the fact that you have this information on the secure device and on the secure screen. So this is what is different with Ledger. But for this ERP7730, it's for any wallet. Anyone can use it, and we designed it to make it public good. So we definitely encourage anyone in the space, if you're a wallet, to use the standard, to contribute to it. So now we have the public registry, but we also have the tool that is the process of creating the file. So more than welcome, we are welcoming everyone in the space to contribute in this ERC and this registry.
On the security side of things, how do you ensure the integrity and authenticity of the metadata file?
Yeah, it's a very good question. So as I said, this is a public good. This is an open registry. Like anyone can commit its own metadata file. And then what we will have on this registry is like a big map that maps the different smart contracts with the metadata file. And then it's up to the wallet to trust this metadata file. And in cryptography, when you want to trust something and to give like authenticity plus integrity granted, what you do is signing it. So Ledger is going to sign this metadata file with a Ledger root key, so that on the device the device has guarantees that this metadata file is the legitimate one, and this is the Uniswap metadata file. And so yes, definitely authenticity and integrity is important. And the way we designed the ERC7730 is up to the wallet to create that authenticity plus integrity guarantees by simply finding the metadata file. It's pretty simple. And on the ledger devices, if you know a little bit the architecture of Ledger, so Ledger is by default the trust authority, the root of trust when it comes to verifying a signature on device. But you can also add your own custom certificates on the Ledger device. So it's on the developer documentation. So you can create your own certification authority. So you create your own certificate. You load the certificate inside the device. And whenever you want to authenticate some file, what you will do is to sign your file with your certificate, the private key of the certificate, so that the device can recognize the signature. So, long story short, by default, Ledger is the root of trust, certification authority when it comes to creating authenticity plus integrity by signing stuff. But as a developer, if you want to become your own certification authority, this is something that is possible.
What would you say the next steps are in terms of implementation?
So for us, in terms of implementation, the next steps are really to discuss with the different apps in the ecosystem so that they can work on this metadata file and create them. Also, for now, there are a few patterns that are missing. For instance, if you are doing a nested transaction, so transaction inside another transaction. So this pattern for now is not properly supported, and this is on our roadmap, and this will be the case in the coming weeks. So this is one of the items that is still on the list. Also, if you are using a proxy smart contract with different pattern, and you are deploying plenty of smart contract automatically, this is another pattern that is not yet well supported, and this is also on the roadmap, and it will come on the weeks to come. So it's not supported by the tool that is generating the metadata file, but if you want to create your metadata file by hand, it's possible. So this part is supported. And what is not supported also is on Ledger device. If you receive there's metadata file that describe nested transaction with smart contract proxies. For now, it's not supported by the Ethereum app running on the Ledger device. So for us, the immediate next steps for completing the clear signing initiative on Ledger devices are really the two ones. First of all, supporting nested transaction inside transaction at the tools that generate the metadata file level and at the device level, and same applies with the proxy contracts.
One question that I have is about supply chain issues. So we know that the Bybit attack was based on a supply chain attack by the Lazarus group. Now, if we look at what steps should the whole community and all the companies working in crypto, all the groups, all the teams, what should they do to make sure that such supply chain attacks do not happen to them? I think even if you upload malicious firmware into your hardware wallet, potentially you can fall into the the same issue. If the hardware wallet, for example, issuer gets into the same kind of attack situation, what mitigations should the community do to prevent against this, in your opinion?
Yeah, this is a very, very good question. Supply chain attacks are definitely a big attack vector, and it must be taken into account very carefully. So you mentioned the way we are. So supply chain attacks is also a threat vector for Ledger, and the way we are mitigating it is the following. So there are plenty of different security layer, obviously, but the main idea is first of all to use secure elements. So this is the chips, the circuits that you have on Ledger devices, and the secure elements are manufactured by ST Microelectronics, which is one of the leaders in the world of secure elements, and they are manufacturing their secure element especially for Ledger. That means that only Ledger can load its own code within the secure element, and it's done with cryptography guarantees. And when it comes to the development of firmware and firmware upgrade, so we have several levels of security in order to avoid compromission at the network level, at the endpoint level, and all of this. But also when we are issuing a new version of the firmware, we have a quorum of different people at Ledger that are reviewing the new version of the firmware and that are checking if everything is okay, if there was no backdoor on everything, and then they will sign this new version of the firmware. So again, this is a mix of, first of all, secure hardware. So we have a root of trust using HSM. It's a mix of organization. So at Ledger, we have different people that are required to sign an upgrade when it comes to signing the firmware upgrade. We also have dedicated security team that are analyzing the new version of the code and so on. We also have another security team that is in charge of looking at the cyber security threat with different point of detection and mitigation and all of this. So at the end, security is really a matter of implementing the defense in depth, and the way we are approaching the issue is this. So based on secure hardware, based on cryptography, every time that you can use cryptography to have security guarantees, you have to do it. And also, it's about process. So process means you implement a process with different columns, with different safe nets, and also you need to be able to audit your process, to make sure that the process that you have implemented is well documented and that is also properly audited quite often. And the last thing I want to mention about this is you have to keep in mind that security is not static. It's more like a journey. You always need to raise the bar for security. And when such an event as a Bybit attack happens, you need to think about your security posture and wonder what would have happened if they let out try to attack you. Is your level of security sufficient when it comes to governance, when it comes to defense in depth, when it comes to detecting the attackers and so on? So I'm with you. Supply chain attacks is the big threat vector. And unfortunately, I don't have one magic answer. This is a collection of answers that you need to take a specific care, a big attention to this. And just to give you an idea, at Ledger we have two security teams. One which is really focused on the product security trying to find vulnerability on the product and making sure that the food chain is secure, and this is about 15 to 20 people. And we have another team that is dedicated to cybersecurity, and it's a team of something like 10 people. So at Ledger, we are investing a lot on this, and you always must be very humble and always try to improve what you have and keep an adversarial thinking mind, because this is the way you will be able to improve your process.
Yeah, thank you for your time, Charles. And thank you to the Ledger team for everything that you guys do to make sure that our coins are safe. If you want to get involved in pushing the standard forward, please reach out to Charles or the Ledger team. It would really help to make sure that we know what we're signing and we don't have another Bybit incident. So thanks, Charles.
Thank you for having me, and thank you for everyone who will help us making the ecosystem a more secure place. Thank you.
Moving on, we have Gnome from Alchemy. You want to give a quick intro and talk about what Alchemy is doing on the account side of things?
Yeah, for sure. Thanks, Jason, and thank you guys for having us. It's going to be hard to follow that masterclass from Charles on all things security, but I'll do my best. Hey, everyone, I'm Noam. I'm head of engineering at Alchemy. Most of you are probably familiar with us for a few products, but a lot of the work we've been investing in for the past 2 years has been around wallets and improving the UX and security of wallets in Ethereum. So we've been working with a lot of folks from the EF on helping the second transition, as is called in Metallic's blog, from EOAs to smart accounts, and building out tools and infrastructure to make adoption of smart accounts simpler and more intuitive for developers and easier to use for end users. And another big transition coming out in Pectra that we're really excited about is what's been dubbed smart EOAs with EIP 7702 that I'm happy to chat about with you guys as well.
Awesome. Let's start there. So could you give an overview of what exactly you're building for EIP 7702?
Yes, of course. Anyone can go check it out at alchemy.com/smart-wallets. And there's a demo at demo.com/alchemy. But the core product is plug and play smart wallets for developers. So you can get all the benefits of smart wallets invisibly in the context of your application. So from the basics of things like batch execution and gas abstraction to higher level concepts like session keys or account automation, or not necessarily for 7702, but things like multi-sigs. And we enable developers to choose between 7702 once live. So you can go play with it today on Zaboya and on mainnet soon, or full smart accounts via ERC 4337. One quick tidbit, because I think it's not super commonly known, but the difference between an EIP and an ERC is that EIPs are in protocol. So 7702 is coming out as part of a protocol change in Pectra. ERCs are out of protocol. So ERC 4337 is all with out of protocol infrastructure enabling smart accounts. And that enables faster development and doesn't require hard forks. So just calling out a point that I think trips some people up sometimes. We do support both in alchemy.com/smartwallets.
Yeah, one thing that I'd like to note here is that for 7702, smart accounts, like the conversion of the EOA into a smart account with 7702, actually is compatible with all the infrastructure that is used for 4337.
Yeah,
just so everyone knows.
Call out. I think a lot of the public discourse has often been, should I use EIP 7702 or should I use ERC 4337? And to your exact point, I think the best framing is, can I use EIP 7702 with ERC 4337? And that the contracts that are delegated to in 7702 can be ERC 4337 compatible smart accounts, and the relaying infrastructure for relaying transactions to that delegated contract can be ERC 4337 bundlers, and all the interfaces for gas abstraction can be exactly the same. So you get the benefits of a standardized hardened stack for using 7702 as well.
As a developer, now having these two new account standards might be confusing. How do you kind of teach developers and like walk them through which one they should be thinking about for which use cases?
Yeah, that's a fantastic question, and it's one that we get a lot. I think high level, if you're a developer building a new application from scratch, we recommend you start with full smart accounts, so ERC 4237. In that, like everything, there are trade-offs in this space, and the trade-off that 7702 makes is you trade off some degree of security and durability for convenience. And the convenience is you can upgrade existing accounts. So like if I already have a wallet, it can be upgraded to get some smart account functionality. But there are some security trade-offs to 7702 that make it slightly less robust than 4237. So if you don't need that in-place upgrade and you're just starting from scratch, you might as well start with full smart accounts from day one. In general, I think there is a lot of confusion here. I think Yoav from the EF is putting out a lot of good content here if folks want to check that out. And for the most part, we're doing our best to try to abstract away as much of this complexity from developers because, as you mentioned, there's a lot of confusion right now in the space.
Yeah. So one of the features that you would lose if you go with a 7702 smart account or delegated account instead of a smart contract account from the start would be that the private key of that account will always have control over the EOA or the EOA delegated account. Even if you have tried to rotate the keys that are controlling the smart account, that private key can always change the delegation or remove it, maintaining control of the EOA. Whereas in smart accounts, this is not the case. If you rotate the keys, the old keys will never be able to have access to that wallet, even if they were the creator or the wallet was created using those keys. So yeah, that's a difference that could make a problem for some people. Not make a problem. Sorry. Let's use a better expression. Could be a difference to some people. Like they would choose to do manual rotation of keys, and they don't want to always have their private key being having super user abilities over their account.
Yes, I think that's exactly right. And in general, for any high value use case, we think this is important to keep in mind. I think 7702 may be great for a lot of in-place consumer upgrades, but is, like you said, still has seed phrases and all of the associated problems with those. And for use cases like we talked about, Charles mentioned earlier, Bybit, but like in no world would these high value use cases that custody a lot of funds use 7702 because you can always circumvent any validation using the root EOA. Another example where that comes up is Alchemy has a rollups as a service offering, and the rollup contracts on the L1 are all owned by full smart accounts with multi-sig controls. And those two cannot be 7702 ever because the EOA in 7702 can bypass any multi-sig validation requirements. So it's not nearly as secure as a full smart account.
What applications have you seen benefit the most from ERC 4337? What have people been building?
High level, all of them. I think I'd recommend everyone check out Vitalik's 3 transitions blog post that came out maybe a year or two back now, but he called out 3 core transitions that he thinks are going to be needed to get mainstream users on chain. The first is the migration from L1 to L2 and getting users to cheaper block space and hopefully stage 2 block space soon. So the same trust assumptions as using Ethereum. The second transition is getting users from EOAs to smart accounts. He actually calls this the security transition. And smart accounts help unilaterally improve a lot of the security issues that we've seen in crypto to date. So, phishing attacks, passkeys, the fact that you have a single point of failure for your account causes a whole host of downstream problems. And then the UX of that is also limited because you have to be ultra secure about the single point of failure. It limits what you can do from the user experience perspective. So I would actually say that pretty much every application benefits from smart account functionality, and every application benefits from the lack of seed phrases and the decoupling of keys and accounts in the 4227 model. But a lot of applications already depend on, like, for example, user context. Like if I have a MetaMask and I've been using it for quite a while, and instead of having to transfer all my assets and all my history from that MetaMask, if I can upgrade it in place and get some of these UX benefits today, that is definitely a large step forward for Ethereum UX. And so if that is required, 7702 fills a big gap there.
Got it. Thank you. Have you seen any security challenges you kind of weren't expecting building with 4337?
That's a good question. I think there's always the smart contract risk, right? I think we put a lot of emphasis into that at Alchemy, and a lot of other teams in this space do as well. Like Safe has been paving the way for a few years now in terms of on-chain security. And then I think beyond like technical security, I think the implementation complexity can lead to certain corner cases where security is in question. We've seen this come up a lot with the context of embedded wallets too, where applications may have more control over user funds than they do in pop-up wallets like MetaMask. And so enabling a paradigm where users maintain control over their assets, everything is self-sovereign. Apps can request permissions to take certain actions. So an example maybe is subscription payments. Instead of me logging into Netflix once a month to send 10 USDC, I can issue Netflix a session key. That session key only has permissions to transfer 10 USDC once per month and nothing else. And then they can manage that key to draft their payments and move to a pool payments model. But there's along the way a lot of issues that arise around like, well, how do we enable developers to safely define the policies and permissions on these keys? How do we provide the right interface to users so that they know what they're signing, as Charles mentioned earlier, and kind of unilaterally tackling a whole host of security-related challenges as developers move to adopt smart accounts?
What's been the biggest hurdle on your end of actually adopt smart accounts?
That's a great question. I think the developer experience has continually improved, but that's still a key area for focus. In that, like any new abstraction, it adds some complexity. I think an analogy I think about often is just in the early days of the internet, you had a static client and a server, and that client would just fetch, static content from the server. And there was no dynamic interfaces. And if you wanted new content, you'd have to click a link or refresh the page. And over time, more and more abstractions entered the stack. So things like Ajax and dynamic JavaScript. And now if you look at a modern web app, say an Instagram or something like that, the amount of abstractions between the client and the server is in the dozens, right? There's all these proxies and edge routers and CDNs and various other pieces of infrastructure that have built in. And like these abstractions all combine to provide what is an incredibly seamless user experience. Like the user experience on an Instagram is probably several orders of magnitude cleaner than the user experience on a static website in the 90s. But the developer complexity has increased in equal proportion. And the job that we're trying to tackle at Alchemy is like, how do we wrangle this developer complexity and give developers access to these robust primitives without having to deal with all of the nuances of implementing these various different technically deep concepts. So making it as simple as possible and continue to keep our foot on the gas in doing so. And I'll say it's not just Alchemy, the whole smart account ecosystem partnering together. I know Ledger's been doing some work here. There's a lot of good work from folks like Circle and obviously the EF's 4227 team. And it's kind of a cohesive effort from the whole community to help streamline adoption of smart accounts.
One question that I would like to ask is, do the apps need to do anything to support these new types of wallets, that 7702 wallets, or even any smart account wallet for that? For this.
It's a good question.
Yeah.
The short answer is yes. There are some changes with how dApps interface with accounts, ranging from how you validate signatures. So, for example, 1271 signature validation may need to be extended to something like 6492, which can validate signatures of a counterfactual, which is like the address a smart account would be deployed to. You get a lot of complexity arising from the fact that your key public address is not your account public address. Like your account is a smart contract on the blockchain in the 4227 model, and your key can be one of many signers on that account, which increases like any sort of public address related operation in the client. And then the last piece I'll call out for now, I'm sure there's many more, is that today 4227 transactions are bundled in user ops via a bundler into a single Ethereum transaction. And that means that any smart account transaction is reflected as an internal transaction on Ethereum, which requires more tooling and infrastructure to parse versus the top level transaction that Etherscans tend to show today.
Do you need to use the bundler? I think that 7702 still gives you the ability to submit your own transactions with your own private key. No?
You can still submit your own transactions with your own private key. Things like gas abstraction and any sort of account automation-based transaction relaying will still need a relay for your transactions. And no one's saying you have to use 4237, but 4237 is great because it's hardened, it's standardized, so many different teams offer it. You avoid situations like vendor lock-in. And over time, it's going to move towards the full native AA model and provide in protocols such as a persistence. So we'd recommend using any sort of standardized interface versus anything proprietary that might lock you into a particular vendor, a particular design decision. But yeah, you're right. You can also relay your own transactions to 7702, but there are many use cases where that is not sufficient.
Yeah, one other thing you mentioned was that dApps need to adapt the signing EIP. You said that they need to not only utilize the EC recover or verify the signature of the private key of the account, but also use the EIP. I forget the numbers because there's so many.
So
I think there's
1271, which is verifying smart contract signatures, and then there's 6492, which is verifying counterfactual signatures.
Oh, yeah. So can you talk more about 6492? Because I don't think it's something that is widely known,
yes,
even to me.
Yeah, I'm happy to. So a smart account, usually because you have to deploy a contract, there's a cost associated with it. The deployment of the account itself is commonly batched with the first transaction a user makes. So let's, for example, say I want to gaslessly mint an NFT, and I previously haven't used this. I previously don't have an account or haven't used this application. Then when I hit the mint NFT button, what happens is my smart account gets deployed based off of the owner private key to a specific address. And the same transaction, I will batch that in with the mint NFT transaction and sponsor this whole user operation. So from the user's perspective, they only sign one transaction and click a button once. But under the scenes, their account gets deployed and they collect this NFT at the same time. And the address this account will be deployed to based off of the private key that deploys this address. So there are many situations where you may want to sign for ownership of the account. Say like, hey, I own this smart account, but that account hasn't been deployed yet because you haven't transacted on the blockchain. And so in that instance, the address that your account will be deployed to is called a counterfactual. And there's an EIP 6492, I believe, from the Ambire team that lets you prove ownership over the counterfactual. So it extends signing and verifying smart contract signatures to include undeployed smart accounts. So signatures that prove ownership of the counterfactual address. Does that make sense?
Yeah, that's very cool. Thank you.
If you had a magic wand and could change anything about the Ethereum protocol, what would you change?
Good question. Honestly, I'm super excited for 2025. Ethereum's getting its swagger back. I think the new executive directors have already made a huge impact. There's a lot of focus on the axis Ethereum wants to compete on. I love the anticipation for Pectra. I think we're talking about 7702, but the fact that the blob count, target blob count doubles is going to be huge for rollups. And I love the focus to accelerate Fusaka, which will include PeerDAS, and again, improve a lot of the data availability requirements for rollups. So I think a lot's on the right track. I think continuing to balance accelerating the key components of the protocol while minimizing client complexity. I know there's been some discussions around things like EOF and whether that should be in protocol or not. But I'm personally really excited about 7702. I'm excited about PeerDAS, and I'm excited about the path to native account abstraction. So whether 7701 with EOF or 7560 without EOF, I think both are great options and continue to improve the user experience and security of Ethereum, and in parallel, continue to develop the DA roadmap to enable more and more users to onboard L2.
Ethereum is getting a progress. I love it.
Yeah, it's awesome to see, man. I think people are excited. There's a lot of momentum in the space. I think people are going to be really shocked by how much progress is made in 2025, both on the technical product roadmap for Ethereum. I think Fusaka is going to come earlier than people expect, but also just the broader adoption of Ethereum. Like at Alchemy, we're having some really exciting conversations with a lot of really big companies, and like not even in crypto, and they're all really excited to build on Ethereum. So excited to continue to develop the tools that enable them to do that. Excited to continue to develop the protocol to make it cheaper and safer for them to use. But there's a lot that's going to happen. And in general, I think a lot of teams are helping accelerate this trend. One thing Alchemy is doing, we call it the Everyone on Chain Fund, but we're putting out grants to help developers adopt smart accounts on rollups. So think of it as a combination of transition 1 and transition 2 from earlier. We're putting out gas grants so developers can just sponsor all the transactions of applications without worrying about that cost. We're putting out grants to enable account abstraction infrastructure. So like Alchemy's managed 47 services on new rollups for free. So all rollups get account abstraction from day one. And we're putting out just like compute unit grants so that developers get free Alchemy if they're building with smart accounts on rollups. So our North Star is just removing the friction from anyone getting started. We want to make the developer experience easier. We want to reduce the capital requirements. We want to increase the availability and tooling. And we're really excited about the opportunity for Ethereum in 2025 and excited to partner with you all to make that a reality.
One question that I have about Alchemy is, so can anyone deploy that infrastructure required to have support for Alchemy smart account on their rollup? Like, is there public docs on how to deploy the infrastructure needed or self-host it? Or does the rollup need to contact Alchemy to host this for them?
So everything we've built for account abstraction is open source. You can check it out at github.com/alchemy platform. Like I said, we have a strong belief in no vendor lock-in. We think open source accelerates this roadmap for everybody. And we're excited to do our part in contributing to the space. So we have our bundler has been the most adopted ERC-47 bundler. It's been being run by Alchemy. It's being run by Coinbase developer platform. It's being run by the base team, I think a few other teams, and it's proxied most of the user ops in the space. Anyone can go up and run that. We have a Telegram support channel where we help folks get up and running. All of our smart accounts are open source, both the 457 flavors and the 7702 flavors. We have some really exciting new announcements coming there shortly too. And anyone's welcome to take all this infrastructure and run it on any rollup. We want to make the Alchemy managed services self-serve at some point too. But for now, if you're running a rollup and you want Alchemy infrastructure, just contact us and we're happy to get you set up.
That's awesome. Thank you.
So we focus on what Alchemy is doing so much more. Is there anything else you'd like to highlight?
Sorry, Jason, you cut out for a second there. Do you mind saying that one more time?
Yeah, no worries. So we focus mostly on accounts here, but Alchemy is doing so much more. Is there anything else you'd like to highlight?
I can give a quick overview of Alchemy really offers 4 things today. I think people historically have known us for running reliable, scalable nodes, and we still do that. High billions of developer requests per day. It's been incredible to see the growth across the EVM ecosystem and a lot of these rollups really taking off. We do offer a rollups as a service product too that has gained a lot of traction in the past year. We power some of the biggest chains in the ecosystem like World Chain. We've been really excited to partner with them. And I think they are an excellent case study of putting all of these pieces together. They are running a rollup at scale, and they're also running this with smart accounts. So they use 4TD7 infrastructure to provide secure, seamless experiences for the World app. And they combine these 2 things. So we recently rolled out on World Chain Sepolia something called Priority Block Space for Humans that uses signature aggregation in 4TD7 to combine a bunch of World ID proofs from user ops into a single bundled transaction, and then using rollup boost can prioritize that transaction at top of block for less gas. So the end result is that for World ID verified users, they get priority inclusion in World Chain blocks, which I think is like a really cool use case for rollups. So that is Alchemy Rollups. Alchemy Wallets is obviously the smart account stack, so plug and play embedded smart wallets, but including all of the 457 infrastructure contracts and SDKs you need to get started there. Alchemy Nodes is reliable node access at scale. And then we have Alchemy Data, including things like NFT APIs, wallet APIs. We have streaming solutions like custom GraphQL webhooks, and we have indexing solutions like subgraphs so that any developer can get access to any data they need in any format.
Awesome. So it sounds like we have in place with account abstraction, low fee. So what do you think the biggest problem is preventing mainstream adoption now?
I think if you were to ask me this like 3 months ago, I would have said regulatory blockers. I think at least in the United States, a lot of those are starting to get a lot of clarity. So there's been a flurry of legislature over the past few weeks that have changed the rules here for existing banks, fintechs, and asset managers to come build on Ethereum. So, there's the Stablecoin Act that I believe just passed, and there were some repeals of previous legislation like SAB 121 that just enable these institutions to actually start building products in the space. And I think they get a lot of value out of building on crypto rails. You get a global settlement platform with, pretty much immediate global settlement, really cheap costs, fast finality. And especially with rollups, there's a lot of really economically interesting properties for these companies because you cannot guarantee transaction inclusion. They're censorship resistant, but you can play with transaction ordering like WorldChain is doing with priority block space for humans in a way that lets them customize the execution layer in the context of their application. I think we're seeing Base lead the way here too, for example, with I don't know if you guys have seen, but Coinbase One subscribers, for example, get access to free gas on Base. So all of these things let bigger institutions come in and define their own financial execution rails that let them move money worldwide faster than they're doing today on their existing systems. And they're really excited about the opportunity, and the regulatory guardrails are off. So a lot of them are expressing much more interest than we've seen in the past.
We are running out of time here. Is there anything that you want to talk about that I didn't ask about yet?
Not really. I mean, we'd love to work with anyone building with smart accounts, building with rollups. If you have any questions, my DMs are open. Check out the Everyone on Chain Fund. It's really for everyone. We want to streamline any friction in getting started and building applications on chain. And yeah, I mean, shout out to the Ethereum Foundation, and want to double click. Really feels like it's got its swagger back. I think morale is high. Momentum is picking up. A lot of pieces are falling in place, and I'm really excited to continue on this roadmap with y'all in 2025.
I'm extremely fired up after hearing you talk. Thank you to Charles as well and the Ledger team for everything that they're doing on the security side of things. Thank you, Noam, for your time, and the Alchemy team, and pushing accounts and infra and everything else that you guys are doing for. And a final thank you to Smart Programmer for being up here and asking questions with and everything that you do at Nethermind. And I hope everyone has a great rest of your day. The ticker is ETH.
The ticker is ETH. Thanks, Jason. Thanks, Smart Programmer. See you guys.
Thank you. Bye.